Okay, thank you very much. Last time, if you guys remember, that we started discussing about Gantt charts and network diagrams. And today, we are going to uh, learn about a technique that is used to calculate an expected time for a certain activity. Yes. So, for this purpose, uh, you know, you should first understand the background. When you are preparing a project plan, in the project plan you also mention the duration of the project. Now, this duration depends on the durations of the activities. Summing up the duration for the activities gives us the overall duration of the project. Now, some activities are running in parallel in the project, and some activities they are dependent. So, those activities which are dependent, normally they have some probability of delay in their start, because if the activity on which they are dependent that is delayed, then that activity is also delayed. However, sometimes this dependence does not delay because there are normally some slack times. So we also today will learn how to calculate the slack time within an activity, that for how much time, if an activity is delayed, that is possible. So today we are going to see a technique, program evaluation review technique. It is a technique that uses optimistic, pessimistic and realistic time to determine the expected task duration. Now you need to understand first, before we calculate the expected time, you should understand what is pessimistic time, what is optimistic time, and what is realistic time. So, from the general meaning of pessimistic and optimistic, that optimistic is used in a positive sense, whereas pessimistic is used in the opposite sense. Now, if I say you are optimistic in doing a certain task, that means you are quite hopeful, right? If I say you are pessimistic in your approach, that means you have some fears. You are confused, it may or may not be completed. But if you are optimistic, you are pretty sure about your destination. Being optimistic, if in reality it takes, let's say, 30 minutes to arrive your home from the university, so being optimistic, I can say yes, I can arrive in 20 minutes or 25 minutes. Okay, I can arrive early. But in pessimistic, I may think of, no, 30 minutes is not enough, so I may need more, 35 minutes or 40 minutes. So now we first need to understand, if pessimistic and optimistic approaches or times are clear, then we can use a simple formula to calculate expected duration. This expected duration is based on the formula. If you look here, that this is a weighted average which is utilizing optimistic time, pessimistic time and realistic time. You can see here that this is a weighted average, because optimistic time is taken just once, whereas pessimistic time, it is also taken as once, whereas realistic time, the weightage of realistic time is 4 times the optimistic and pessimistic time. So what we are doing here, so we are adding up the number of times we are taking them and then dividing by 6. So that gives us an average expected time. So if, for instance, you look at this example, in this example we have given certain activities. For instance, requirements collection, screen design, report design, database design, user documentation, programming, testing, and then installation. All these activities, they are representing the systems development life cycle, or some of them among the systems life cycle. Now in the second column you can see that a time estimate is given in weeks, and you can see 3 further columns here where this is optimistic time. Okay, so if you are optimistic, you can say that I will complete requirements collection task in 1 day, to be optimistic. However, to be pessimistic, it can take 9 weeks. This is 1 week and this is 9 weeks, but in reality it may take around 5. So real time, in fact, that lies between somewhere pessimistic and optimistic time normally. Okay, screen design takes 5 weeks being optimistic and 7 weeks being pessimistic. Now these week times are given. Once these week times are given, you can calculate the expected time for each task. Now expected time for requirements collection is about 5 weeks, neither 1 week nor 9 week, but it is 5 week. This is 6 week, 2 weeks, it is 5.5 weeks, 5 weeks, 3 weeks and 1 week. Huh? Yes, in fact, since we are taking an average, so being optimistic, the shortest possible time, and being pessimistic, that is the highest possible time. When you take an average, that lies in between somewhere, both of them. So this is the expected duration. Now this activity, this expected duration is shown. That is shown for each activity in the Gantt chart, because you saw an example of a Gantt chart. It was showing certain number of days in the second column. If you go back, for instance, look here, some time is given here in order to perform these activities. Now indeed, yes. Normally these are the estimated or expected times, because in the planning it is very difficult in the beginning to measure precisely the accurate time for any activity in order to complete it. However, this does not mean that if it is not possible precisely to measure, then we should not give the deadlines. We have to fix. Otherwise, project would not come to an end. That would keep on delaying. So, from this formula, we have calculated the estimated times for a certain project. Now, we need to understand critical path. It is actually a scheduling technique whose order and duration of a sequence of tasks, activities directly affect the completion. If when you design or when you schedule, the activities involved in the project, so as I said earlier, that there is always some chances for an activity to be delayed. But sometimes for some activities it is not possible to delay them. If we delay some activities, then it will delay the overall completion of the project. Now, because of this, the completion of the project will be affected, which is not desired ultimately. So, we need to determine a critical path, that what is the shortest possible time in which a project can be completed. Now, we will understand how to determine the critical path using the Gantt chart. We will do certain calculations, and based on those calculations, we will prepare a tabular data and then we'll analyze it. And from that table, it would be clear to us, or it would become clear that which activity can be delayed by how much amount of time and which activity not. So, slack time is an activity, it is the time an activity can be delayed without delaying the project. Yes. In fact, the critical path is the shortest possible path. So, if there is a slack time, this means there is a possibility of the delay. So, when there is a possibility of the delay, that does not remain the shortest possible time to complete the project. So, critical path is always without those activities who do not have the slack time. Okay. Now, you can see here the example is same, but here we have added one more column describing about the preceding activities, the activities which are performed earlier than the specified activities. So, you can see here requirements collection, there is no preceding activity, right? Screen designing is an activity, the interface you see on the screen for any application. Then there is report designing. Normally you print out the reports at the end after doing some work or doing some transactions. For instance, if you go to ATM, you withdraw some cash. At the end, it generates a small report about the transaction, how much you have withdrawn from your account and how much is left behind. So that's a kind of, that receipt is a kind of report that let us know about the status. So this report or any other similar reports, they do have some contents on them. So we need to design them, that what information should be displayed, in what order, in what sequence, and so on. Then database design is dependent on activity 2 and 3. Documentation activity is dependent on activity 4. Programming also on 4. Testing depends on 6. Installation depends on 5 and 7. Okay. Now, if we are given the specified activities and the preceding activities, we can draw the network diagram, right? Now, if you look at this, these circles are showing us the activities. Okay? Well, you have to hold down. To determine critical path, we need to have certain calculations, and those calculations are based on our earliest possible completion times and latest possible completion times. The amount of time in which an activity can be completed in an earliest possible time or the maximum possible time, right? So here we can see that we have drawn the network diagram, and activity 2 and 3, you see there that the preceding activity for 2 and 3 is activity 1, and this was specified in the chart, in the table. For 2 and 3 we have the preceding activity as 1. Now you see the activities 2 and 3 both are the preceding activities for activity 4. So we can say, we can draw an activity 4 here, which is representing the database design, and 2 and 3 are preceding it. So similar,
what is the critical path?
Critical path is the shortest time in which the project can be completed, or it is the time before which a project cannot be completed. We can say that this is the amount of time that project must take in its completion. Right? Clear? So similarly, we can continue and keep on drawing the activities, following them the preceding activities. So for instance, when you finally draw an activity 8, that is preceded by the activities 5 and 7. Okay. Now, after this whole diagram is completed, we have to calculate latest possible completion time and earliest possible completion time. How to determine the critical path? Calculate the earliest possible completion time for each activity by summing the activity times in the longest path to the activity. This gives the total expected project time. So, we will calculate earliest possible time for each activity and then we will sum up together. That would give us the expected time for the overall project. Just hold down. Hold down. Unless you do not understand what are the latest or earliest possible completion times, it would be difficult for you to understand the critical path. Now, after that, we have to calculate the latest possible completion time for each activity by subtracting the activity times in the path following the activity from the total expected time. So, in earliest completion time, we were summing up the activity times, but here we would be subtracting the activity times, and this gives us the slack time for the activities at the end. And this lag time we will see wherever the earliest and latest times they are equal and same, there is no slack time. But if there is some difference, we will see that there is certain possibility of slack time. Now, critical path in fact contains, as I said earlier, no activities with the slack time. Okay. Now, if you look at this figure, this is the same figure, right, that we have drawn earlier, this one. The only thing what we have done, we have removed the name of the activities. So, we have only numbered them 1, 2, 3. 3 means the activity is referring to the reporting design. Now, you can see here that an activity is labeled with 3 different numbers. One is the expected time, and this expected time was actually given in the table when we in the earlier table, this one, right, 5, 6, 6, 2, 5.5, 5, 3 and 1. So, we have already calculated these expected times, and these are now shown with the activities on the network diagram. So, you can see activity 5 has the expected time as 5.5. Now, other than expected times, we have to calculate 2 other different times. One of them is earliest time. Now, forget about the latest time at this moment. First we will calculate earliest time. For activity 1 or the activity from where we are going to start, for that particular activity, earliest possible time is the same as the expected time for that activity. Since the expected time for this activity is 5, so the earliest time is also 5. We will start from the expected time. Now we have to calculate this earliest time for each following activity by summing up the previous activity times. Now if you look for activity 2, earliest time is 11. You should understand how it was calculated. It is based on the expected time of activity 6 plus the earliest time of the preceding activity. Right? Now, similarly, to calculate an earliest time for any activity, you need to calculate the sum that depends on the expected time of the activity itself plus the earliest time of the preceding activity. So we sum them up and it gives us the earliest time for that activity. Remember, expected time is different, earliest time will be different, and latest time is supposed to be different. After calculation, if they remain same, that doesn't matter. So please do not confuse the expected time with either earliest time or the latest time. So for instance, look at activity 3. What is the expected time for this? That is 6, whereas the earliest time is 11. So earliest time is calculated by summing up the expected time and the earliest time of the previous activity. Is that clear or no? Right? Okay. Now, you see, for both of them, we have calculated the earliest time for activity 2 and 3. Now I have a question to you. First, we calculated the earliest time for activity 1, then we calculated for activity 2, and then we calculated for activity 3. So please you should keep in mind that it is recommended that you should calculate the earliest times for all the activities which are following from activity 1, which are initiated or coming from activity 1. Now once all the activities are completed, we can go further. So now activity 4 has two preceding activities. Or in other words, activity 2 is followed by activity 4 and activity 3 is also followed by activity 4. Now 4 is dependent on two activities. So we need to calculate its earliest. Earliest means how early, right? How much early you can do this job. If I give you, let's say, 15 minutes to do certain task, how early you can do? Somebody say, I will do it in 10 minutes. The other guy would say, I can do it 5 minutes. But less than 5 minutes, it is not possible. So 5 minutes is the earliest possible completion time for that activity. Right? Okay. Now, you see here, earliest time is 13. What is the expected time for this? 2 plus 11. 13. Then 2 plus 11 is 13. If both of them are same, this means if the earliest time for activity 4 that is calculated as the same earliest time depending on the two different preceding activities, then you can take any one. It is the same. So the earliest time is 13. But sometimes what happens? If you calculate the earliest time for activity 4 depending on activity 2 would be different from the earliest time depending on activity 3. So in that case you would have to choose the minimum.
I think you have to sum expect time with the latest time.
Sorry?
I think you have to sum the expect time for 4 with the activity latest time. Minimum to finish together.
What do you mean?
The latest time.
Mm-hmm.
You can sum the expected time. You cannot finish the.
Okay. Now you have to calculate earliest time for activity 5. So it depends on expected time plus the earliest time of the preceding. So 13 plus 5.5 gives us 18.5. Similarly, for activity 6, 5 plus 13 gives us 18. Then we come to activity 7. It has expected time as 3 plus the earliest time of the preceding activity. 18 plus 3 equals 21. Now we have the final activity. Now this final activity also have how many preceding activities? 2. 5 and 7. So again we will have to compute the earliest time from both activities. For instance, you calculate from here. One plus 18.5, that gives 19.5, and then expected time plus earliest time. This is 21 plus 22. Oh, okay. I think there is confusion. Yes? Any problem?